Alright, time for another draftphysics.com, debatephysics.com also. But again, you can't really engage physics in any kind of conversation about what they believe. Like religious people, they really don't want to talk about the truth or facts. Just how incredibly stupid what they're doing is, in the sense that the origin is just a cabal of 10 people deciding what the truth is, and they're just indoctrinated into a bunch of silly axioms of reality. A holy ghost, for example. Why would anybody fall for that? Anyway, I mean, the story's dumb enough. Why throw that in? But anyway. So, yes, physics is wrong. You don't have to get causes right as long as you get effects right, so to speak. So most of theoretical physics, defining what's behind the curtain, is just wrong. And yes, there is an Oz. There's a flame popping up and a voice coming out. And that part we can all agree on. But yes, we're not going to agree on what's causing that. And I'm not going to agree just because the story is on its face ridiculous. So their energy theory says it takes 25 times the fuel to move something 5 times as fast. Idiotic. Doesn't happen. Nonsense. Just ridiculous. And then they have this double slit phenomenon where they convert it into this silly nonsense about particles being in the same place, and then particles interacting and communicating with each other in some way, and all kinds of silly nonsense to explain something really simple, in the sense that obviously surfaces are causing the effect, and obviously photons, if I shoot them through a hole, some of them go near the surface, and if they do, they get messed up, and the pieces get thrown somewhere, and then the pieces can be put back together. So there's a really simple explanation, and a particle model can explain. So I guess that's where we start with that phrase, often used by physicists, that no particle model can explain. Well, they haven't really thought about any particle models. They didn't consider any. They didn't try to imagine any. They didn't do anything to demonstrate that to be true, except to point out that nobody has suggested one. Now, somebody has suggested one, but now they're so used to saying it that they're not even listening to anybody else who says anything different. You might argue that Einstein was arguing for something more mechanical and real than spooky action, even though his own theory of gravity was pretty spooky. So, that's the context. You can consider yourself somebody because you saw it. The truth, that will actually exist someday when the physicists grow up and have to concede they've made some mistakes. The AI will probably reconfigure the origins and put together some of this stuff that's really obvious, and it'll fall on it, trip over it, and say, what about this? All of the computer power that they have wasted because they have these wrong axioms. They're putting wrong information into the simulator, and so it can't get the right answer because the rules they create are stupid. And if they put these right answers in, they could probably by now, computers could simulate so much more very accurately. But anyway, I will do some of that in this video, and I have produced a simulation that does the basic thing that you need to do, which is explain why electrons and protons attract, and why electrons repel electrons and protons repel protons, and to do it in exactly, it fits perfectly with Maxwellian standards or drawings of charges. and it's really dirt simple, and it's got to be the right answer because is so much simpler. I mean, it's actually 1,000,000 times simpler than superpositions and entanglement. Yeah, it's 1,000,000 times simpler than that. The standard model is absolute convoluted nonsense. They say it actually does something somewhere useful, but they just say so. I don't think it has done anything. I don't think it's engineered anything, invented anything, because it's convoluted nonsense. Antimatter, all kinds of wacky properties, that the simplest things in the universe are supposed to have. Electrons, for example, are one thing. They're a little negatively charged object. They don't have dipole moments. They don't have a magnetic field, or all of the crap they spew. So anyway, the particle model is this simple. There's two kinds of force bit. It's a thing. Force is stuff in the universe. The stuff moving the speed of light. So when some thing is transmitted at the speed of light, it's transmitting by just this stuff, this little tiny bits of stuff. And if you put them at a frequency, the little bits, you'll create what's called a photon. And if you have some other pattern of the bits, you can create magnetism. And so it's not making more bits, it's just changing when bits hit something, or in what pattern they hit something. And that can sort of be seen in the whole idea that to detect a photon, usually what you're going to do is cause it to create electricity. So it's and vice versa, frankly. And that relationship is a relationship of basically, the idea is you're going to cause a cascade. You're going to cause electrons to move from atom to atom, or at least their pressure to move from one atom to another atom. And clearly in the extreme case, the pressure gets great enough to release the electron itself from the surface. And so it's just about inspiring momentum, and that becomes a simple tipping point argument. And so I've made this so many times, but it's just so obvious that if an electron is attracted to a proton and it's stuck in proximity to it, and you hit it, okay, it's going to move every electron in the proximity. It's always in balance with other electrons, so it's an elastic object. So it's like hitting a stick that's in gravity, and if you hit it slowly, it can wobble back and stay where it is. Okay, so you could throw 3 things at it at 50 miles an hour, let's say, and it doesn't tip over. But if I throw the 3 things quickly enough, that is dot 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 instead of dot dot dot, so obviously red frequency versus blue frequency, then I will just keep adding the energy while it's still moving. And that's the key factor, while it's still pressurizing rather than depressurizing. So it's basically you're just adding it before it collapses. You're adding more, so you get more velocity and therefore more capacity for something interesting to happen. So yes, that's how you tip things over. You tip things over by recognizing it has a resonant frequency, and that if you hit if you hit super resonant, that is before it even decides to start going back, before it even starts to oscillate, so it has a velocity, and you hit it again and give it more velocity, obviously. And so that simple principle can be understood, and once you understand that principle, you understand it's not what you're throwing. That is, the 4 bits don't have different amounts of energy. Okay, 3 bits of red light is not different than 3 bits of ultraviolet light in terms of the amount of energy. It just has to do with that timed factor. And the fact is, you can defeat the elastic systems by hitting them quickly. Yeah, that's it. It's not more energy, it's just energy delivered in a form that can do something that looks like more work, but it isn't actually moving more matter. So like the karate chopper breaking boards, it's not really about having more energy. It's about delivering the energy more effectively to defeat the structure of the wood. So that's all it is. There's not more energy. There's just energy delivered in a certain way. And the same thing happens with bullets and recoiling guns. Recoiling gun hits you, okay, it might give you a bruise, might be uncomfortable. That is if I shot a gun and just let it go and hit you. Okay, it's going to be the 1,000 atoms hitting you 1 mile an hour, and it's going to be spread over a larger surface, and there's going to be lots of facts where it's not going to do much damage. And the bullet obviously will do lots of catastrophic damage because all the energy is being delivered to a small location, and it's being delivered in a short period of time, which is the key factor to breaking atoms, is time. Alright, so that's more physics than I wanted this video to be. But there's really no way to explain this without just pointing out that a simple mechanical mass velocity momentum theory does explain everything. So you really can explain everything once you have this mechanism that creates repulsion, attraction. You've got the pieces, and then you just expand on those little pieces. And like I said, if they didn't listen to Bohr ruined physics. Okay, his stupid orbiting thing with the electron, all wrong. His electric model, you could argue, of the atom versus a magnetic model was just a catastrophic mistake. But you could argue that the bigger mistake made earlier was this notion that there's something called kinetic energy in the form of 1/2 mv squared, which implies that as you put energy in smaller objects, that somehow you make more and more of it. The momentum turns into quadratically increasing amounts of something called energy, and it just doesn't exist. And so that's demonstrated by rockets and ballistic pendulums and levers and balances and all kinds of things that demonstrate it don't happen. Okay, it doesn't exist. It doesn't do any work. Momentum moves rockets. Momentum moves ballistic pendulums. Momentum moves anything that's moving. All right. So there's two kinds of force and two kinds of matter. So you can just say, look, there's electrons and protons. Those are solidly understood elements because of the whole charge scenario and the fact that it gives you the opportunity to create a dipole, plus and a minus. And that's really the beginning. And so the two kinds of force are just twins of, it's probably a better word, of the matter. So there's electron force and electrons, and then there's proton force and protons. And so it could just be easily understood as if you just draw it as red and blue or green and black, or any kind of way to differentiate north from south, so to speak. And that's what the universe is made out of. Now, the actual what they're actually made of, why a proton can tell the difference between electron force and proton force, could be because they're triangles and one's square. Could be lots of different things that are allowing them to see that difference. Point is, it's a difference. The protons and the electrons see the difference, and they function differently. So you have the electron and the proton. Now their charge is the same, and so you really have to argue they have to be the same visual size, because frankly the entire universe is made of straight line force, and line of sight is how it runs. So everything's line of sight. And but clearly protons end up in nucleuses in a higher proportion, so you could argue that maybe they're heavier. And so that creates one little weirdness in the story, but there's an explanation. It seems the simplest explanation for why nucleuses are made out of protons and not electrons. That is, they say there's antimatter, but frankly there's no antimatter. There's no evidence of its existence. Obviously, I think there's no evidence of its existence. Just because of the whole annihilations arguments and everything. There's just no way the universe could have been made out of it. Anyway, the force, tiny, discrete little bits, could be infinitesimally small. So this is one of the arguments made, is that photons don't interact with photons. Well, that could be true because, frankly, the size of the little force bits could be gazillions of times tinier than the thing they're going to give momentum to. There's no size rules here. And so just by size, they can never hit each other, just because the space they're actually traveling through is so much bigger than the space we see them in. But anyway, and we just can't see how much room they have to navigate because they're so small. So that's an argument of unknown value. Obviously, particles can also hit each other and perfectly reflect, which means you have exactly what happened. Exactly what went in comes back out. So all of the bits that hit each other could just make perfect kinetic exchanges, and so this is going this way and this is going that way, and now this is going that way and this is going this way, kind of thing. But it seems clear that the two forces, that is electron force and proton force, can't interact in any way unless they interact with electrons and protons. Alright, so still, it's physics, okay? So I'd like to say, look, this is so simple, I can just, it's really simple mechanically, but you have to undo all the crap you already have in your head, and that's the part that just makes this more complicated. So the simple truth is, okay, just understand, you have the force bits, they have all of the velocity. So all of the velocity is here in the force bits. And the matter doesn't do anything until force forces it to. Okay, so that's really needs to be understood. So you can think of this as the bits that are alive, and these are the dead bits. That's actually how they talked 300 years ago. Live energy and dead energy. Well, they didn't use the word energy. But anyway, all the velocity is here in the speed of light, and the reasonable, kind of well established by evidence rules is that all this stuff is the same. So there's no fluctuation in these bits. They all have the same quantum of energy. And so they're a mass moving at a very high velocity. Very small mass, very high velocity. And basically, because they interact with electrons and protons, they will either be absorbed by an electron, reflected by an electron, or converted by an electron. That's going to be the big one. So we might as well leave that up. So these are the three. So you have two kinds of force, two kinds of matter. So you have just these little solid hunks of mass, electrons and protons. All the electrons are the same, all the protons are the same mass. Alright, and you have the little bits of force, which is all the stuff you know is photons. And the stuff you don't know is photons. That is the heat. The heat is infrared when it's radiant heat. All the stuff moving has force stuck to it. Or you have force flying through space and it's going to hit something. So in space you can't run away from the force, right? Anywhere in space, there's a ton of photons of all different variety, from radio to gamma, hitting you. You know, that's the reality of space. And depending on where you are, there's places in space where, because of the amount of atoms in the space, let's just say, there's all kinds of changes that can take place in what kind of energy you're going to get hit by, what kind of radiation there is, and all kinds of things. So, what form the photons will be in can change. The fact that they exist can't change. So again, that's one of the simple rules, is none of this can be destroyed and none of this can be destroyed. And all you can do is change how this is interacting with that. That is, how much of it is pushing matter and how much of it's free. So you could argue that gravity, okay, in the universe is really just about how much force is moving matter. Because the more of it's moving matter, that means the more of it's trapped doing stuff like this instead of flying through the universe at the speed of light, creating pressure. And this particle model does explain gravity, no problem. Gravity is just converting force into the motion of matter. So force comes in from the external universe, hits the matter, pushes it, is now occupied pushing it, and pushing it consumes time. So the force can't get out the other side. Right? Just a fact. In the same time, it needs to balance the thing sitting on the other side of the planet. So if you're sitting here on this side and the force goes in this way, it gets slowed down here, and you're not going to feel it because it didn't get to you in time. And that's the differential that creates gravity. So anytime there's matter, the force is going to hit it, and it's going to get absorbed by it. That is, it's going to move the matter, and moving the matter slows the force down. Therefore, it won't get where it would have been. And that simple differential explains gravity. And then you just have the drag problem, which I just took care of in my last video. So we'll go into that right now, but you really can't. There is no such thing as drag in the real universe, because the force, all you can change is when something gets to a location. You can't change really that it will. Alright, so let's just go through these three basic ideas. So if the electron isn't moving and a force bit hits it, that is an electron force. So this is a proton, so let's use that as the example. So here's a proton. You hit it with a piece of proton force, it will stick, the proton force, if it doesn't have any motion, and it'll move at some percentage of the speed of light. You hit it again from the same direction, then it'll be a higher percentage of the speed of light. And then if you hit it again from the same direction, it'll be even a higher percentage of the speed of light. So now you can see why these photons having a smaller and smaller frequency means they can get more done, is because obviously they can get these protons or electrons up to a much higher speed, okay, before something else happens to stop it. So that's the trick. So if it's moving in the same direction as the force, at some much slower speed, of course, then it can, and it gets hit in that direction, the little bit of force will stick. So more than one bit can stick. Probably should have done that in red. Yeah, probably should have. That'll determine how fast you get the proton or electron to go. So obviously these rules apply to electrons. It's just that electron force thing. So that's the simple absorption argument. If it's coming from the opposite direction, okay, that's in this example. So in this example, I should have started with an arrow going this way. Alright, so there was already one stuck to this electron. Okay, then you hit it with a force, coming from this direction. And what's going to happen is like a kinetic ball. It's like a Newton's cradle, and you have two come in and they just pop back out again. You're just going to get a perfect reflection. So because it was going this way, okay, it was going, I really did mess this up a little. It was going this way. It had this force bit was stuck to it, so I shouldn't have said the other way around. And you came in with a force this way. Then both of them end up being released. So let's say you had 3 bits of energy going this way. The last little bit will pop off, and this one will reflect. And so this will lose 1 unit of its momentum. So if it had 3 units of momentum, now it only has 2 units of momentum, because it lost one of its force elements through this interaction. So now you can understand why something, yes, plowing into the field will stop you. But, okay, if the field catches up, it will push you forward again. But anyway, so you can understand it can't go in both directions. It can't collect force in both directions. So all it can have is one direction. So the matter can't really move in more than one direction. It can only have its direction altered. So if something comes in at an angle, well then yes, it's going to add that vector and it's going to change which way it's going, simply. Alright, so that's reflection. And then you have the third thing that can happen that really is the whole story, which is this conversion thing. That is, an electron force hits a proton, for example, or a proton force hits an electron. It doesn't matter. And it's converted into the same orientation. So the electron force goes in, proton force comes out. And that's why there's charge. So that simple change, that simple function of the inverse relationship between the two forces hitting each other creates the mechanism that allows you to have attraction and repulsion. And it's that simple. It's just this simple element where you just allow there to be this transformation. Because now what you're going to create, okay, what that means is that each proton only emits proton force. Nothing else can come out of it. So no matter what goes in, proton force comes out of a proton. And likewise, no matter what goes into an electron force comes out of an electron. So even if a bunch of red stuff goes in, obviously it's just going to come out blue. And so you end up with these two perfect charges, in the sense that you have two emitters emitting these opposite forces that have the simple property is that the blue force pushes blue objects, the red force pushes red objects. It either accelerates or decelerates. So you could argue that reflection is a deceleration. So there's acceleration. You could call absorption acceleration. You could call reflection deceleration. And the conversion has no effect on momentum of the object. It just converts the force. And that simple, those simple pieces now give you everything. Because this is everything. Charge is everything. Okay, the idea of this being negative force and this being positive. Okay, the idea of these two being the opposites. And there's you can perfectly understand now that, well, any electron force coming from here can't get to this electron, right? It's going to get turned into red force. You can almost see that. And the red force is inert. It's going to come out blue force. So the electron won't be moved by the red force. And obviously this side, all the blue force that hits from this side, it will cause either deceleration or acceleration towards the positive. So you can understand why they just get smashed right into each other. That's what's going to be the clear function, is strong attraction. And obviously if I have two of them next to each other, you could understand that all the red force coming this way, say if I had another electron right here, all the red force coming this way and all the red force coming this way is going to be converted into blue force. And so now that all the red force is going to be blue force, okay, pushing on both of these objects, decelerating them or accelerating them away. Okay, so strong repulsion will be created. So that simple mechanism, two kinds of force, two kinds of matter, three kinds of interaction, done. That's the building blocks, all the building blocks you need to model everything that happens in the universe. Because everything that happens in the universe will involve these three functions between electrons and protons. The simple force and these simple functions. And everything that happens is explainable, because this is the real universe. This is all there is in the real universe. There's electrons and protons in the real empty space. Okay, we're in a fluid where, you know, we have no idea what empty space is because we're nowhere near it, frankly. But that's the real universe. The real universe is these little tiny things, and that's all there is. There's just electrons and protons and this force stuff. And so everything that happens, all of this complex stuff I'm doing, yeah, it's really interesting and funky and strange, but it's all caused by this. This has to do it first. A bunch of electrons and protons trapped in all kinds of bizarre configurations have to bend and move and flow and fiddle around in all kinds of ways, and it all happens in, you know, quadrillionths of a second, because it's a speed of light force, and these are little tiny things, and they're very, very close to each other. You know, an apple is to the earth, you know, what an atom is to an apple. I mean, there's this is an insanely small universe, but that's the real one. That's the one where everything happens. Nothing happens out here. Nothing's happening here in this universe in the sense of mechanically that isn't this. This universe did it first. It's just, I don't know, you know, and so that's just something you really need to understand. I have no properties. These are the only properties that exist that are real mechanical properties. Everything else, we're not really seeing the mechanics. You're not seeing, you know, this isn't visually connectable. Okay, you can't, oh, I can see the electrons. No, you can't see it. But that's actually what took place. A gigantic number, 10 to the 20th kind of number of events take place in every second of our conscious experience. These things are doing a billion years from our perspective. A billion years of interactions are taking place. A billion years of videos, okay, are taking place in 1 second. Okay, in their world. Their world, you know, an insane amount of actions happened in what we consider a tiny amount of time. I mean, these are all things to understand. I mean, you know, our perspective is so distorted. I mean, the whole idea that suns, you know, have a lifespan of 10 billion years. And so, you know, you look at a galaxy and only, you know, so few of them are supernovaing. Well, that's because their life cycle is so long and so slow that you're never going to see it. It's like watching a Galapagos tortoise die or something. It just doesn't, you know, it just doesn't happen often enough. And you know, because of the time scales. And, you know, we're trapped between, you know, a universe we can see that's in this insanely long time scales and this small universe where an insane amount of stuff happens in a millisecond. So anyway, so I'll get to a more elaborate drawing of the charge, I suppose, and just point out how you can start building nucleuses really easily, and that there's a logic to the actual truth, and it fits if you really understand the actual truth, the actual experiments, the actual the facts, the actual facts, not the BS they have taught you. Alright, so here's a view of the simulation that's still being worked on. Not quite, making it square was a mistake because it broke the pure randomness of the external energy, blah, 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 blah. But the idea is easily visualized in the sense that you do get this strong attraction and repulsion from the opposites, and this is basically forming what you could understand as a reasonable dipole. Now, if this, I guess I have to use the mouse over here, yeah. If this one just swings over to here and the other red one pops over here, you have what is common hydrogen. This hydrogen is in a 2-molecule form. So people say hydrogen, they just say, oh, it's an atom of hydrogen. Well, no, it's really a molecule, and it contains 2 hydrogen atoms. So the hydrogen that they're using to, shoot rockets and do all this stuff is H2. Okay, it's not just hydrogen. And the shape of it, okay, you could understand is, if you understand that the hydrogen is basically, our definition of it is the electron and proton in association. Well, the 2 part means that the 2 atoms, obviously if they are dipoles, and I put the 2 dipoles next to each other, it's like 2 magnets sticking to each other. It makes perfectly good sense. So anyway, the point is I'm just showing you that it does form. You can see there's another one over here that's going to eventually sneak over there. They clump. Okay. Now, it doesn't clump fast. So you're saying, all right, I've given you this model that it's just, you don't need this. I mean, you can just see this is the reality. Okay, I'm just saying this is what the real universe looks like. The real universe is just electrons and protons and these little bits of shit moving at the speed of light in dead straight lines. And those interactions, that's the universe. That's the only universe. And this stuff is just, a side effect of that function. Alright. What do I want to hit? I want to hit this, and then I'll do some drawing, so I'll pause. Alright, so, this is where you have to make some sort of accusation about, well, why did physics make such a mess out of this? And it's the same argument you could argue about religion and how the first theories stick with people. They become traditions, habits, addictions, and they just can't let them go. They're indoctrinated into it. It's a cultural thing, the stagnation of memes and ideas, and and so Bohr created this, which I just would think that people would say, oh, come on, it can't be like that, because he tried to model the atom as the solar system, and that's really looking at it the wrong way. I mean, what you really want to model is dipoles, magnets, because magnets are giving you a giveaway, right? Magnets are this red-blue thing, positive, negative, north, south, okay? And you can understand that dipole concept because you say, yeah, I can break the magnet anywhere, and it creates 2 similar magnets because it's just an alternating thing. It's a north, a south, a north, a south, a north, a south. And no matter where I break it, I'm always going to have a south down there and a north up there if I consider the magnet to be unbreakable at the middle. So whenever I combine them, I only can break them here or break them here. well, I'm always going to have south that way, and I'm always going to have north that way. And it's sort of giving you a clue that, well, it's magnetism all the way down. It's dipoles all the way down. And, not this crazy orbiting weird thingy. Just didn't make any sense. And they made up all these fake rules that somehow, because the electron is spinning around here, that somehow it's doing work. It's creating a magnetic field, and so it's running out of energy, and it's going to crash into the proton. All kinds of nonsense. All right, so anyway, so what I have observed in making the simulation is that the rules, of absorption, reflection, conversion, and when you draw them, they say, okay, everything should just smash together, right? So all the atoms in the universe, all the electrons and protons should immediately just do this, and become dipoles. But the catch is, is that there's a bunch of this, there's a bunch of electrons and protons. And I could make the argument, every time an electron moves, you can understand that the field that's hitting it, the little bits, it's changing the period at which they reflect. So if I move my hand, I'm essentially, if I could move my hand fast enough, you'd see my hand actually turn blue, because it's going to blue shift. It's going to create a more compact frequency. And if I expanded my hand quickly enough, you wouldn't see it at all, because no photons could hit it, right? But you can see it's going to expand the frequency. So anything reflecting off my hand, if it's moving away, is going to get red, and it's going to get redder and redder until it's an invisible red. So you can understand that that's what these are all existing in. It's a very noisy universe, in the sense that it's not just dot, 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 all precise in exactly the same location. It's little bunch here, and then a very expanded bunch over here. So it's all kinds of variety of pressure. So everything's being jostled, by more extreme amounts. There's not like just a little shudder. There's, a photon hit me, so I moved this far. And a blue one hit me, so I moved even further. Because of the fact that I did it before anything could get to stop me. I moved before it could stop me, effectively, decelerate me. And that's what's actually, things are jittering. So what I found in the simulation, I made the simulation, I had somebody who did the programming, and by the rules, and it just seemed it did take a little. Everything just kind of blah 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 blah, and it takes a while. And when it gets a certain distance, and then it turns into what you'd expect, a proton stuck to an electron. But it doesn't happen as quickly as you would expect. And the truth is, it doesn't happen because this motion, the fact is everything's going to move, but it's going to move side to side. So the electron and proton are like magnets trying to find each other, but they're doing this too much. So they can't find each other, and they're doing this, and they're getting moved in different directions. It's three-dimensional space. Can you understand? 3 dimensions. So they're getting jostled in 3 dimensions, and that's why they can't just smash into each other until they get really close, because it's the inverse square law kind of rule, right? The charges are produced, and like as Maxwell would sort of point out, you just count how many lines you break, you intersect, and you can know how strong the force is. So if you're close, you're going to intersect lots of lines. You're far away, you're going to intersect very few lines. Inverse square law, it's separating this way and this way. That's what the inverse square law means, is that the space your paint has to hit, say it's little particles of paint, the space it has to hit is now getting bigger both directions. So your canvas is getting bigger and bigger and bigger, but the amount of paint is the same. So your specks of paint are going to get further and further apart. And so it's, the force diminishes with distance and gets very strong close up. Anyway. So so that's an observation, is the real universe is noisy because there is all these other electrons and protons all over the place. They're all over the place. And there keeps sending microwaves and infrared and all kinds of different frequencies of the force at you. And those different frequencies carry with them different amounts of jitter and shudder. And so the electrons and protons are stuck. So this is the textbook, okay, which is wrong description, right? It's just an electron and a proton. So let's understand also Bohr's model of, the big giant proton and a little tiny electron. You know from charge that they can't really have a different profile because the charge strength is the same. That is, what they're radiating has the same visual profile, or they couldn't have the same charge. It's like saying they have to have the same gravity. Yes, gravity doesn't matter what size they are. It just matters what their mass is. And in this case, size is going to matter because we're talking about an excreted force. That is, so it has to be able to hit it. If you make it a singularity, it can't hit it. Nothing can hit it. The only way the proton can have charge or reveal itself to exist is it has to be able to convert the blue force into the red force. If it doesn't do the conversion of blue into red, it can't attract the electron. Okay, so yeah, I just want to make that point that this is wrong. Okay, they have to be the same size, and it's simple enough to say, yeah, protons are just heavier, harder to move. Anyway, so that model, though, is just nonsense, and all you're really doing is creating neutrons, frankly. So the compression of the sun is basically just saying, here's hydrogen, I'm going to make a neutron. A neutron basically is, I actually did get the proton and the electron really close. So now they can't go too far because it's a very strong force very close. So their jittering doesn't make much difference anymore because they're, but neutrons don't survive out in empty space. So they are degraded. So they need to be in an environment that's relatively quiet, not that lacks force, but one that has a consistent amount of force, so they don't jitter too much. You start jittering them, they start falling apart. And they say, whatever, it takes 15 minutes for that to happen, or 8 minutes, or some stupid number. Anyway, but that's what, hydrogen is really just a variety. A neutron is hydrogen. So this goes back to the whole idea that, yeah, you want to have some elemental thing that all the atoms are made out of. And people, 300 years ago, 200 years ago, did speculate about that kind of idea, that this elemental dipole is what everything else is made out of. You just make a bunch of these dipoles and put them together, and you make all the other atoms out of the same pieces. And it's effectively very much the truth. Okay. And so Rutherford, who Bohr extrapolated on, his diagram was much different. And I don't remember if he had any orbiting crap going on, but the point is he understood that the nucleus did have electrons in it. Okay, so this is before they discovered the neutron. And the simple argument is that, yes, the nucleuses are always, of more complex atoms, the nucleus is always net positive, but it's net positive in the sense that it still has the binding agent of the, wow, that's not very bright, of the relationship between electrons and protons. So, I think it could be understood that if I did have a proton, an electron, and a proton, okay, then I have a 2-to-1 relationship. This object, if I took this and started just building nucleuses, I'd end up with the right proportions to build other atoms, in the sense that I always end up with a net positive nucleus, okay, and what I really have is a neutron plus a proton. And and it's a very, you could look at this object and you say, yes, this would make sense, because the electron is basically hiding the other proton from the other proton. One proton can't see the other proton because there's an electron converting the force, making the force moot. So all the root force coming out of the proton from one side or the other side gets converted into electron force, which just passes through it, and so it's irrelevant. And then you could understand that if I knock that out, there'd be this tremendous problem that you have two protons right next to each other. All of the electron force will be converted into proton force between them. And so the pressure here will go up extremely high, extremely quickly. And that's your chain reaction, nuclear bomb, blah, 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 blah. That's the strong force. So there is no strong force. There's no singularities. There's no superposition. There's no entanglement. There's no quantum fields. There's no antimatter. There's no any of the crap they say. So there's pretty much no point in me saying there's no strong force. I mean, and you can sort of understand, isn't the strong force just a holy ghost? It's just a placeholder. They just made it up. Oh, this is a magical force that only happens in proximity that pushes protons together in some magical way. When no, if you want to get two protons together, you just stick an electron in between them. Maxwell could have told you that. I mean, that's how charges work. If I could take a north magnet, I can take a south magnet and a south magnet, and I get the two south magnets very close if I have a north magnet in between them. Not a problem. So, you know, it's not that hard to figure out that you don't need a strong force if you understand charge at all. If you pay any attention to Maxwell's drawings, you could understand that if I have two positives and I want to get them close together, I just stick a negative between the two. There, problem solved. They're now close together. So anyway, Rutherford's model included the electron. So a real nucleus is going to be an object, you know, again, that's going to have twice as many protons. And just forget about neutrons. Neutrons aren't a thing. Okay, they aren't a particle themselves. They're made of these particles. So the real nucleus is going to be this mixture where you have a 2-to-1, generally speaking, relationship between the number of protons and the number of electrons. All right, so let's go to that construction. I guess somewhere in this, I should just draw the real hydrogen. Okay, real hydrogen looks like this. So, you know, it's, this one goes here. So it's just basically two dipoles. Okay, and so you can understand that it's still in the atmosphere. So these would be further apart than I drew them. But you could see how this makes perfectly good sense. Yes, the electrons repel each other, protons repel each other, but there's strong attraction to, there's two electrons for this proton to be attracted to. Yeah, get it? And so there's good reason for there to be this, for this to be the form that hydrogen would take. That it would just naturally fall into that pattern. So say if it was, in this form, where it's pretty far apart, and another hydrogen atom got close to it. So it's doing this jiggling thing, they can't get closer to each other, but obviously the closer they do get, this is going to help pull the hydrogens together. All right. And when you do that, you end up with this. And then you get into deuterium and tritium, which is pretty much just making the argument that all you're doing is consolidating, these dipoles. You're consolidating the pluses and the minuses and arranging them in a way that maximizes their attraction and reduces their repulsion. And that's the key to the whole thing is made out of that. So it's very easy to make helium out of this and on and on. I don't know whether I need to go into that, so I'll think about the summing up of this section. But this is the basic function. This is how you build a nucleus. So this whole idea that hydrogen is a thing, the element, the real element of the universe, you really have to understand it. But it's really constructing, if you take hydrogen and just compress it, you have the neutron. And the neutron isn't neutral. It's got equal amounts of both charges. So it could look neutral from certain directions, right? If I looked at the neutron from down here, it's going to look like a proton. It's going to be red force. I look from it up here, it's going to look like an electron. It's going to be a repulsive electron force. But if I look at it from the side, I'm going to get a mixture of the two. I'm going to get the purple. So from the side, I could say, yes, it's neutral, right? So depending on the perspective, it'll look like something, but it's not really neutral. It's the first dipole, and it's both the magnetic and the electric dipole in some sense. Now the electric dipole, I shouldn't say that, just because this is a nuclear object. Okay, it's not on the outside of atoms, it's on the inside of atoms. And the polarity that makes electricity possible is really just to do with, well, I did that the wrong color. You know, the fact that you do have a net positive nucleus and you have electrons on the outside, and that's the polarity. And the interesting thing there is, can't see that at all. Oh no, there it is. You can see it barely. Electrons on the outside. And the interesting thing there is you can have a polarity in more than one direction. So atoms can be dipoles, tripoles, quadpoles. So they could have a polarity this way and this way. And I would argue that iron creates that kind of environment where the domain switching really just has to do with the fact that they can just rotate. And when they rotate, they can just go from this pole to this pole. And if they go to this pole, then this one automatically goes to this pole, and the next one goes to this pole, and the next one. So there's a symmetry built in. And you can, you know, again, noise breaks the symmetry. So heat or vibration breaks the symmetry. And you're really just talking about creating these compatible environments where the configuration is maintained without it getting too chaotic and jiggled. And that you can do under the extreme conditions of high pressure, because the high pressure is only creatable by having a bunch of matter as a dampening agent. It's taking out all the little vibrations and just turning them into just big vibrations. Alright. Well, I am pause and see if we can sum this one up. Alright, on the website draftphysics.com, I do have all of the subjects that are, you know, these important foundational ones. So charge is explained in the first video, then gravity and energy and photons and magnetism. Yes, those videos are okay. You know, maybe it could be better. And that's what these videos will be eventually, is just to make the explanations more and more understandable, and to do what I can to fix any misunderstandings I allow there to be. Now, I'd argue that the only critics I get so far really aren't arguing any of the arguments I'm making. They're arguing arguments I didn't make. And statements I didn't make, and ignoring explanations I have already provided. So the real point is that this simple explanation, this simple model, this theoretical physics theory does provide a groundwork for explaining everything, and there's no woo. You don't need 400 different particles. You don't need antimatter. You don't need entanglements. You don't need any of that nonsense to explain these functions, which really are just transfers of momentum. That's all that can really take place in the universe, is the momentum goes from being free little bits of force to causing some motion in electrons and protons. And the electrons and protons have force between them, so they change the force between them when they move, and therefore cause each other to spooky action to move. But obviously it's real. There's a real carrier for the force, and it's not doesn't just happen. And as stated, it's a push-averse. There's only the capacity to push. There isn't any pulls. There's only an absence of an equal push. You don't have the equal push from this side and you have a push from that side. Well, then you're going to go that way. And that's really how the universe works. It just exchanges of momentum. Momentum is conserved, and you just can't change how much motion there is in the universe. So we're all the way back to Descartes. He was quite correct to speculate that the energy in the universe is just going from object to object, and that's all that's happening. There's no need to refuel it. You can't get rid of the energy, and it's just saying whether somebody that has some, that doesn't have any, that has some, that doesn't, you know. It's just identifying whether something is being propelled or not. And obviously from a relative condition, yes, we can all be moving through space in some equal vector and still have interactions with each other that look like it's the only interaction. But obviously there's actions happening that we can't see. So right now there's a bunch of neutrons and electrons and protons. And neutrons aren't a particle, they're electrons and protons. I should just say electrons and protons moving that way. I can't see that mine are moving that way, but that's what they're doing right now. And then a second later they're going to be going that way, and then all kinds of changes taking place all the time based on the field of force and what planets are doing what. You can't help but be pushed around in different vectors all the time because Earth's gravity, you're moving in space, rotating on the Earth. So obviously your vectors are always changing because the field of gravity that's pushing you towards the center of the Earth is always changing its direction. Alright, so it's just so easy to understand all of it. And so I don't know what to say. You know, it is depressing, okay, that a perfectly valid theory will not be fairly scrutinized by anybody. You can't pay them to pay attention. Right? I've offered thousands of dollars to the talking head physicists, and they all run the hell away. They won't deal with the fact that their physics is wrong, which I has demonstrated, and this physics is frankly indestructibly right. It'll work, and theirs won't, and that's the truth. And they won't let that be known, and they won't let that happen. So yeah, so if you're watching this video in 2005, yeah, you're you know, seeing something that's going to be the truth in the future, because it's the truth now. And it's just a fact that science won't do what science should do, which admit they screwed up. They did create a religion out of physics. Physics is not science. They really haven't proven any of that crap. They don't have they've got the conclusion cart way ahead of the horses. Okay, they've jumped to conclusions, leaped to conclusions based on scant and spooky evidence. Not nearly enough proof to be so confident and to make their declarative statements that we have proven. They haven't proven. Quantum mechanics is not the most proven theory in history. All of that is crap. Again, where is there any shred of proof indicating it takes 25 times the fuel to spin something 5 times as fast? There's nothing like any evidence of that being true, and yet they'll insist it is. And you know, and sadly, the people who really haven't had the time to really immerse themselves in all of the details and all of the experiments and Stern-Gerlach and this and that and all this muons and this and all this stuff that you have to go through to find out all the holes and the gaps that they never shored up. This is a rickety roller coaster, or it's a, you know, it's a mind just waiting to collapse because they haven't built it right. Physics isn't, it's got a lousy foundation. I could argue that right now most physicists would argue that the denting of the clay by Deschartelet back in the 1730s was a legitimate, reasonable experiment proving kinetic energy. And it's garbage. It doesn't, it can't possibly give you a right answer. It's as bad as, shooting arrows, pointy arrow, dull arrow, and then giving them the same energy, and then saying because the pointy arrow went in further, it has more energy. It doesn't have more energy. Alright, so enough said. So till the next time, and such and so forth and whatnot. So I can, I can only do my part. I think I've been reasonable. I've made videos. I've tried to be responsive. Now, obviously, I'm not going to take their insults. I'm not going to be called a science denier and all kinds of other crap without a fight. And, and clearly their obnoxious arrogance is not going to be, you can't do anything with that. You can't fight paranoid, defensive cheaters. And that's what they are. Like, again, they won't argue any of these arguments. Ever. They just won't do it. Like I said, I can't pay them to pay attention to the actual facts illustrated in these videos. Alright, so till the next time and such and so forth and whatnot.